This film was made in 1957 to give a close-up view of the processes used in the fabrication of a piece of jewelry, where enameling and granulation were involved, and where the small scale of the working area and the time involved can take advantage of the techniques of the film. Granulation was used by goldsmiths long before recorded history as a means of embellishing areas by fusing minute spheres of gold to the surface of a gold object. This technique, used from the Viking world in the north through the Mediterranean area to Persia, India, and China, declined after the beginning of the Christian era and eventually became virtually a lost technique. In the Victorian period, jewelers tried to rediscover the methods used in the process. Castellani and later German jewelers developed ways of doing granulation, but their use of granulation and that of contemporary jewelers still cannot challenge the consummate mastery of design and technique evident in the ancient pieces. The technique and its use remains an intriguing technical and aesthetic problem. This film makes it possible to condense the approximate 80 hours used to make this brooch to less than 30 minutes. The idea for a piece of jewelry originates in some vague mental image and takes on more definite form as it's explored through drawings. This particular piece was sparked by a photograph of a European water beetle. The sketches are worked on periodically until one of the drawings captures to a stronger degree than the others the feeling associated with the mental image. This rough sketch usually determines the basic proportions of the piece, but in many ways the design process continues throughout the construction of the piece as you become more involved with the forms and relationships that are developing. The piece, which will form the back of the beetle, is begun by scribing the outline of the shape of the back on a sheet of 18-karat gold, which is a little less than 1/16 of an inch in thickness. The shape is cut from the gold with a jeweler's saw. The saw cuts as the blade is drawn vertically through the metal, and only enough forward pressure is used to keep the saw against the metal. The slightly roughened edge left by the saw is removed with a file. The first forming of the back is done with a small ball-peen hammer on a block of wood or stump. This does not change the thickness of the metal to any great extent, but the piece gradually assumes a cupped form, retaining the original size and contour of the edge of the shape. The hammering is continued with the same hammer against a steel plate. The hammer blows are kept away from the edge so that it retains its original thickness as the central area becomes thinner and the depth of the depression is increased. Hammering hardens the gold and eventually would cause it to crack unless it is returned to a softer, more workable condition by annealing. In this process, the gold is heated to a cherry red color in subdued light and then quenched in water. This allows the structure of the gold to recover from the strain set up by the hammering. These two processes of hammering and annealing are continued until the form has reached the desired depth. A highly polished steel form called a stake is selected, which will fit the general form of the back. Light blows of the planishing hammer develop the subtleties of the form and remove the marks left by the heavier forming hammer. The blows work out from the center in concentric circles until the entire surface has been covered. Planishing allows the craftsman to refine the form and develop its subtleties. When this process has been completed, the piece requires only slight buffing to polish it. The back is now ready for the application of small rectangles of gold, which eventually will form the walls or cloisons bordering the areas of enamel. These rectangles are black due to copper oxide, which has been developed on the surface of the gold by heating them in a kiln about 1300 degrees for a period of time. Each piece is picked up and positioned with a small brush moistened with a solution of gum tragacanth, a vegetable glue. The rectangles are placed end to end to form lines that define the large areas of the back. Standing on edge, these rectangles develop a wall about 1/16 of an inch in height. Traditionally, these walls were made by bending strips of gold wire to fit the form and fusing them in place. The fragmented line achieved by the rectangles produces a line that is less mechanical in feeling. To fuse these rectangles onto the surface, the piece is held in a reducing flame with stainless steel tweezers. The reducing flame turns the copper oxide on the surface to an infinitesimal film of pure copper at a temperature around 1600 degrees. This copper causes the surface of the gold to melt and combine with the copper to form a minute quantity of solder which flows along the joint and fuses the pieces together. Since the temperature is close to the 1700 degree melting point of the 18-karat gold, the work must be brought up to temperature slowly and evenly to prevent overheating any section, and may take as long as 5 or 10 minutes. A hot dilute solution of nitric acid removes the black oxidation formed during the cooling the piece and causes the coating of yellow ochre which protected the undersurface to flake off. The back is burnished to restore the luster by brushing it with a brass brush revolving in a stream of soapy water. Small rectangles of various sizes and thicknesses are used to develop the design within the major areas of the back. This process consumes time and may extend over a period of several days if it's a complex design. Preliminary drawings are used to plan the design, but the pieces are placed on the piece without guidelines. This keeps you more alert to what is developing as the lines and areas take shape, and you can begin to sense the personality of the piece. The upper back and edges were fused to the piece earlier to make it easier to hold the piece now and move it around as it is worked on. These rectangles are made by cutting thin strips from a sheet of gold on a foot-operated metal shear. These strips are then fed back through the shear and cut into rectangles of various lengths. The foot shear makes it possible to cut many at a time and provides a clean right angle edge. The copper oxide is developed on the surface by heating them for several minutes in electric kiln at a temperature of 1300 degrees. When the piece is finally ready for the fusing process, it's relatively fragile. Yet the glue will keep the rectangles in place, even after the heat of the flame has changed the glue to carbon. The piece is heated on a heavy iron screen. The effect of the flame is first seen as the tragacanth darkens and becomes carbon. In parts of this sequence, the changes are speeded up as the camera was run at 1/3 normal speed. Gradually, the rectangles change from black to copper color, and finally the surface of the rectangles glistens as the copper unites with the gold and forms a film of liquid solder on the surface. This film of solder flows into the joint and bonds the pieces together. It's difficult to see the actual flow of the solder into the joint, and you learn to judge what is happening by the way the surface shimmers, as seen in the following close-up. In this view, the piece has been cleaned and burnished, and the fillet of solder along the joint can be seen. An anvil and a planishing hammer are used to forge 14-karat square gold wire to begin the forming of the pieces which will become the legs of the beetle. Gradually the square wire thins and assumes a tapered shape. As the piece thins, the compressed metal flares the flattened end. A rawhide mallet is used to form the curve of the leg against a tapered iron horn stake. Hammering the center of this curved area gives a slight swell to the thickness of the curve. And by hammering the end of the curved section on its other face, the swell of the thickened area is emphasized. Each piece is filed to remove irregularities left by the forming process. Various flat and curved files are used to develop further refinements in the form. To remove file marks, the pieces are gone over with carborundum cloth on a stick. White rouge on a muslin buff, which is revolving at high speed, polishes the pieces. A variety of sizes of rectangles of gold are positioned to provide accents to the line of the leg. These are fused in place by a slightly different process from the one used on the back. Since the 18-karat rectangles are to be attached to a 14-karat base, the base has a lower melting point than the rectangles, and a small pointed flame is used to concentrate the heat at the joint. Flux in the glue keeps the joint from oxidizing and allows the pieces to be welded together. Small grains of gold are also applied to the leg as accents. Here granulation takes place when the granule and the area around it scintillate. In this enlarged close-up, you can see the surface flow and join the granule to the base. A piece of gold will be cut and formed to fit the contour of the back of the body of the beetle. This piece is then filed to fit the contour of the back edge of the front pincers. The two pieces are positioned on a charcoal block supported by a nest of iron wire. The torch flame is used to remove any grease from the joint. High-temperature gold solder in the form of grains is applied with a brush at intervals along the joint, and the joint is flushed with flux. Flux, a form of borax, forms a protective coating which keeps the oxygen in the air from developing oxides on the surface to be soldered. These oxides would prevent the solder from flowing when the metal is heated. This solder melts at 1490 degrees and flows through the joint by capillary action. After soldering, the piece is cleaned by immersing it in a hot dilute solution of sulfuric acid. The first leg to be soldered is clamped in position with stainless steel tweezers. In soldering, the piece is heated over a large area until the temperature is almost at the flow point of the solder. Then the flame is concentrated at the joint, drawing the solder through it. Each adjacent piece is attached with a lower melting point solder, if possible. The piece which will form the head of the beetle is cut out and fastened to a dowel with engraver's pitch. This makes it easier to hold a small piece while it is being filed and formed and eventually polished. Gradually the form is developed with small files. Surface enrichment for this piece is applied in the form of minute balls of gold. These are made by cutting a thin sheet of gold into fine chips, mixed with powdered charcoal, and placed in an iron box. These chips form perfectly round spheres of gold when heated to 2000 degrees in a kiln. They are then separated from the charcoal and sorted according to size with sieves. This section is heated on a stainless steel screen so that the flame can engulf the piece and bring it to temperature without overheating the grains before the base metal comes to temperature. This would cause the grains to have the appearance of being embedded in the surface. They should appear to be just resting on it. Still smaller granules are applied to the unit which will form one of the eyes. The basic form is made by forcing a gold wire into a charcoal block and then melting the exposed end to form a ball. The remaining length of wire provides a means for holding the unit in tweezers while the granules are applied, and it also is used to attach the eye to the head without solder flowing into the granules and flooding them. The head unit is fitted to the body and held in position with soft iron wire while it is soldered in place. The eyes and feelers have been soldered on, and a provision is now made for fastening the back to the body. A rivet fastening will be used to make it possible to separate the two units should it ever become necessary to repair either of them, and to make it possible to fire the enameled section separately. This is done by soldering a tube on the underside of the back, which will pass through a hole in the back plate. The underside of the piece has been counter-enameled, and the piece is now flame cleaned to provide a greaseless surface. The first enamel to be applied has been ground to a fine powder with a mortar and pestle using distilled water. Vitreous enamel is similar to ground glass in its raw state. It is applied to a metal surface and heated in a kiln to its melting point, which causes it to fuse to the surface of the metal as a smooth, glassy covering, which may be opaque or transparent or translucent. This brown enamel will be used to give a blended edge against the cloisons. Several different brown enamels will be used to produce color variations within the darker areas of the design. Transparent yellow is applied to large areas of the back. This color will be altered by thin layers of other colors subsequently fired over it. This produces an effect of depth and color change that is quite different from an area of one solid color. And finally, small accents of a dark brown are applied over the yellow. This completes the first coat. The piece is dried and then placed in an electric kiln, in this case an electric hot plate with a Pyrex cover. At about 1400 degrees, the enamel becomes a layer of molten glass and loses most of the bulk of its previous state. A counter enamel on the underside overcomes the strains caused by the difference in expansion and contraction between the enamel and the gold. This difference is great enough that the gold is stretched to a slightly larger size as the enamel grips it on both sides while cooling. The second coat is a light lavender enamel, which will cause the yellow of the first coat to be less vivid. As water is lost through evaporation, more is added to keep the surface moist and workable. Another firing, a clear, transparent flux and a strong blue are added over the previous coat. In this film, to avoid repetition, several of the firing sequences have been eliminated. Finally, areas of opalescent blue are applied to depressions that have been left for it. The enamel has now reached a height slightly greater than that of the cloisons. To bring the surface to the height of the cloisons, the piece is rubbed with a carborundum stone under running water. This grinds away the high spots and leaves the surface roughened but uniform in thickness. After it has been stoned, it is cleaned and refired to regain the glossy surface. A mixture of pumice and water on a hard felt buff polishes both the enamel and the gold cloisons. White rouge on a muslin buff will complete the polishing of the surface. As a last step, the two sections are fastened together by turning over the edge of the tube which forms the rivet. Also on the back of the piece are the safety clasp and the joint which will hold the pin stem. For the craftsman, there are always two slightly different personalities involved with each piece. There is the one associated with the mental image that he's been trying to bring to life, and the other is the personality that he finally feels in the completed object. No piece seems to come alive in its final form with the intensity of the original conception, but the desire to get closer to that original conception grows stronger with each attempt.